All right, so this is going to be our walkthrough for the derivatives of inverse trig functions homework assignment. So now we've gone through in class how to find the derivative of each of the inverse trig functions. So we're just going to apply the chain rule with them. So we can look at this one as this is a function within a function. It's the inverse sine of u, where u is equal to x squared. So when we do our derivatives, dy du, for the chain rule, should be 1 over root 1 minus u squared, because that's the derivative of inverse sine. And then we'll multiply that by the derivative of u with respect to x using the chain rule, which is just 2x. So we'll end up with dy dx equals 2x over root 1 minus u, which is x squared, squared. And so we'll rewrite this as 2x over root 1 minus x to the fourth, and that should be our final answer. All right, for our next one, we've got the inverse tangent of u. So we'll rewrite this as y equals the inverse tangent u with u equal to x cubed plus 1. It's another function within the function. So the derivative of inverse tangent, we should know, is 1 over 1 plus u squared. And then our derivative of u should just be, I already started writing the derivative there. The derivative of u with respect to x should be 3x squared. Right? And so when we plug these in together with dy dx, right, we're just multiplying the two of them together. We end up with 3x squared over 1 plus x cubed plus 1 squared. And if we simplify that out, it's 3x squared over x cubed plus 1 is going to be x to the 6th plus 2x cubed plus 1. And then we have another 1 to add to that, so that should give us a plus 2. And that should be our final answer. For number 3, here we've got the inverse secant of u. This is y equals the inverse secant of u, where u is equal to x cubed minus 3. So we'll find dy du first. We should know that the derivative of the inverse secant is just 1 over absolute value of u times the square root of u squared minus 1. And our du dx is 3x squared, right? So these are just the derivative of inverse function rules that we should have memorized. So when we multiply those together, we're going to have dy dx is equal to 3x squared divided by the absolute value of x squared minus 3 times the square root of x squared minus 3 squared minus 1. And so we can rewrite this as 3x squared over the absolute value of x squared minus 3 times the square root of, and we'll distribute that out, x squared times x squared, oh, sorry, that was x cubed. Fix that. Those are x cubes, not x squareds. Not sure why I started writing x squareds there. So we'll distribute out the x cubed minus 3. Right? X cubed minus 3 squared should be x to the 6th, and then minus a 6x cubed, and then plus 9. And then if we have a plus 9 with a minus 1, that'll be a plus 8. And that should be our final answer there. And here we've got the inverse cosine of the sine of x. And so for this one, again, it's just, this is y equals inverse cosine of u, where u is equal to sine of x. So the derivative of inverse cosine is, very similar to the derivative of inverse sine. I think we learned that they just differ by a negative sign. So this is negative 1 over root 1 minus u squared. And du dx will just be cosine x. And so when we multiply these together, we end up with negative cosine x over the square root of 1 minus sine squared x as our dy dx. Now this answer is fine. We do know that 1 minus sine squared x is equal to cosine squared x, so we could rewrite this as the square root of cosine squared x. But be careful, if you do that, you might be tempted to say that the negative cosine of x, this is negative cosine of x over cosine of x, which is negative 1, which is not actually always true, right? Because we have to remember that what does the square root of something squared actually reflect? It reflects the absolute value of that thing. So if you want to rewrite it in one of these forms, that's fine. But you can't say unequivocally that the square root of cosine squared x is just equal to cosine x. So we're going to leave it in one of these three forms. For our next one, again, we've got an inverse trig rule here. Right? So we've got y is equal to the inverse cotangent of u, where u is x cubed plus x squared. So our dy du, again, this is the co-function of tangent. So we said that all the co-functions just differ by a negative sign from the original function. So the derivative of inverse cotangent is negative 1 over 1 plus u squared. And our du dx is just 3x squared plus 2x. And so we'll go in and multiply these together, getting dy dx is equal to negative 3x squared plus 2x divided by 1 plus our u of x cubed plus x squared squared. And we should then be able to simplify this out, or just put the negative out in the front there. 3x squared plus 2x in our numerator. And our denominator, we need to expand out x cubed plus x squared. That should be x to the 6th plus 2x to the 5th plus x to the 4th. And then, of course, we have this plus 1. So we'll attach a plus 1 to it. And that should be our final answer for number 5. So halfway there through this assignment. Let's look at number 6, the inverse cosecant of x to the 5th. So this is y equals the inverse cosecant of u, where u is equal to x to the 5th power. So again, this is gonna be dy du is equal to, since it's the co-function of secant, it's just the opposite of the rule for secant. So negative absolute value u times root u squared minus 1. And our du dx, just with the power rule, will be 5x to the 4th. So as we multiply this all out together, we have dy dx is equal to the opposite of 5x to the 4th. And then we have the absolute value of u, so that's the absolute value of x to the 5th. And then we've got the square root of x to the 5th squared, which would be x to the 10th, minus 1. And from here, we should be able to simplify this down just a little bit. We should know that the absolute value of x to the 5th could be rewritten as the absolute value of x to the 4th times the absolute value of x. And then that allows us to do some simplification here, because the absolute value of x to the 4th, well, that's just the same thing as x to the 4th, because x to the 4th is always a positive number, right? So the absolute value of x to the 4th is just equal to x to the 4th, which means I can cancel those two terms. And in the end, we're just left with the opposite of 5 over the absolute value of x times root x to the 10th minus 1. So we'll do a little more practice with the sine, secant, and tangent ones here, just because those ones show up a lot more often than the co-functions do. So if we've got the inverse sine of e to the 2x, we can rewrite this as y equals the inverse sine of u, where u is e to the 2x, and see that we have to use the chain rule. But then we'll recognize also that in order to find the derivative of u, we're going to have to use the chain rule. We're going to have to say u is equal to e to the v, right, because it's e to a function, e to the 2x, where v is equal to 2x. So now we're going to have a chain rule within the chain rule. Our dy du is 1 over root 1 minus u squared. Our du dv is just e to the v, and our dv dx is just 2. So when we multiply all of these things together to get our dy dx, we should end up with a 2e to the v in the numerator, and v is 2x, so we'll write that as 2e to the 2x. And in the denominator, we should end up with root 1 minus u squared. Well, u was equal to e to the 2x, so if I square that, we should recognize that that's a power to a power, so we can multiply those two different exponents together and get e to the 4x. And that should be our final answer for number 7. For number 8, once again, this is just going to be a chain rule within the chain rule. So we've got y equals the inverse tangent of u, where u is equal to the cosine of 5x. And we'll note that that means u is the cosine of v, because 5x is a function within cosine. And now we'll say v is 5x. So we'll have 3 different pieces here to multiply together to get our final derivative. We'll have dy du, which is just 1 over 1 plus u squared. We'll have du dv, which is negative sine of v. And we'll have dv dx, which is just 5. Multiply them all together, we end up with dy dx is equal to the negative 5 sine of v, and v was 5x, so negative 5 sine 5x in the numerator. And then in the denominator, we just have 1 plus u. Well, u is cosine of 5x, and we're squaring that, so it's cosine squared of 5x. And that should be our final answer for number 8. Just a couple more here. For number 9, we've got the inverse sine of the natural log of x. So again, this is just going to be y equals the inverse sine of u, where u is natural log of x. This one's a little bit simpler here because we don't actually have a chain rule within the chain rule, right? We just have natural log of x. So our derivative should be just dy du times du dx. That's going to be 1 over root 1 minus u squared for our inverse sine. And du dx is going to be 1 over x. So now we multiply these two things together. And we should end up with our dy dx equal to 1 over x root 1 minus u squared. And so we often write our natural log of x squared as kind of like we do with the sine and the cosine functions with the trig functions, just natural log squared of x. It just means, right, just means natural log of x squared. Same thing. Alrighty, we got the last one here. We've got the inverse secant of x to the 4th minus 1. So this is y equals the inverse secant of u, where u is equal to x to the 4th minus 1. So if we're going to go through and take our derivatives, we'll have dy du is equal to 1 over absolute value u times root u squared minus 1, because that's the rule that we have memorized for inverse secant. And then we have du dx is just 4x cubed. So to start off with, we'll have dy dx is equal to the product of those two things, 4x cubed over the absolute value of x to the 4th minus 1 times the square root of u, which is x to the 4th minus 1 squared, and then minus 1. So we'll distribute out what's going on there in our denominator. So we'll have 4x cubed over the absolute value of x to the fourth minus 1. And then when we distribute that out, x to the fourth minus 1 squared, right, should be x to the 8 minus 2x to the fourth, and then plus 1. But then we also have this minus 1, so those should cancel out. And then we should be able to do a little extra simplification here. X to the fourth minus 1. And then we could rewrite this. This term right here is the same as x to the fourth times x to the fourth minus 2. Right? And so if I split that into two different radicals, I can then turn the square root of x to the fourth into just x squared. Right? And we don't have to worry about it being the absolute value of x squared because we know that x squared is always positive, and therefore the absolute value is redundant. So what we have here is just x squared, and then the square root of x to the fourth minus 2. And if we simplify that down, the 4x cubed over the x squared is just going to give us a 4x in the numerator. And in the denominator, we'll have absolute value of x to the fourth minus 1 times the square root of x to the fourth minus 2. And that should be our final answer. And that's the end of the walkthrough here for our derivatives of inverse trig functions. We're just going to keep practicing some more derivatives for the rest of this unit.